we are moving on to writing functions. A function is notated as f parentheses x. You have to know this for today. A function is notated as f parentheses x. How you say that is the function of x. That's how, when you see f of x, it means function of x. And I say f of x when I use function notation. You're going to be dealing with it a lot tomorrow too. Your main learning target today is you can write equations for various word problems. So you need to know some vocab words in order to write these equations. Is means equals. Like if I said that there is 33 kids in my class, it means my students equals 33. So you need to know that is equals. You also need to know per means multiply. It's a rate. Do you have it as a rate in your notes?
Yeah.
And then each is also multiply. Okay. First one's not hard. We've done this in Unit 1. So we're given a word phrase and we have to create a numerical expression that goes with it, or a numerical function rule that goes with it. So 5 less than the product of 6 and x is 32. So I know that it should be equals 32. I know that because that's where the is. Now I need to figure out what goes on the left-hand side. 5 less than the product of 6 and x. That tells me when there's two vocab words, there's parentheses involved. So product of 6 and x and 5 less than. Less than means less important. It always goes second. So it should be minus 5. And now I have the product of 6 and x. 6 parentheses x. Or just 6x. It doesn't matter. We use parentheses when the order of operations would give us something different. But here the order of operations would always make us multiply first. So it doesn't really matter that much there. 2 more than the quotient of x and 3 is negative 5. I always put an equal by my is. I always kind of work backwards. I know it's equals negative 5. Now what? Now what goes on the left-hand side? 2 more than the quotient. So I have 2 vocab words again. That does tell me parentheses in case order of operations comes into effect. More than means plus. Quotient is division. As 8th graders, we use a division bar. So 2 more than the quotient of x and 3 is negative 5. Quotient of x and 3 is x over 3 plus 2. 2 more than. You could have it 2 plus x over 3 equals negative 5. You could do that as well, because addition, order doesn't matter. Order only matters with, or doesn't matter with subtraction. Okay. Okay, the next one we have the product of 5 and the sum of x and 9 is 90. So I know something equals 90. I always do that first. Equals 90. Now what? Now is where the parentheses really matter because order of operations would give us a different answer. I have product and sum. So I have 2 vocab words which tells me I need parentheses. So this is the product of 5. There's my parentheses. Product and parentheses are really multiplication, right? And the sum of x and 9, so x plus 9, is 90.
Yeah.
So that's learning objective number 1 for writing a function rule. You need to remember how to do this. You've done this multiple times before. So this was more review, but the key here is that you are noticing vocab words and that is means equals. That's the big takeaway from this one, from this little intro page. Then we move to making equations given a word problem. I have y equals blank x plus blank. That's a function rule. I want you to cross out the right y and go f of x. F parenthesis x. That just means the function. F of x is the same thing as y. It's the same exact thing, it just looks weird. But you're going to see it a lot, especially tomorrow. You're going to see it all the time. And I want you to remember when I did this, linear equations, y equals mx plus b. That was back in our second lesson, and how every equation should look like this. Every linear equation should look like this. So everything you do today should look like this, except have f parenthesis x there, the function of x. What goes in front of the x is the rate. So it's what is changing. Rate is what varies. And then you always add the initial amount. Everything you're given today, if you follow this template, you should have no problem creating a function rule. So let me just reiterate here. It should always be given the function of x is equal to your rate times x plus your initial. So what's changing is this and this. X always stays right after the rate, and f of x will always be the same. So all you really have to identify is your rate and your initial amount. All right, let's apply this. A kennel charges $15 per day to board dogs. Upon arrival, each dog has to have a flea bath. That's $12. Write an equation to see how much it would cost if a dog stayed 8 days. So here's what I know. My f of x is equal to something times x plus something. That's what I would always start out with. I know it needs to look like that. Now what's my rate? What changes? What do you think? What's my rate? What alters? Tell someone next to you instead of zoning out. What changes? Ooh, I heard someone say something. I heard a D word. Days. Days is your rate. You can have your dog there 1 day, you can have your dog there for 6 months. Okay, whatever. The rate is the days you're there. So my rate is 15. That's my rate. See, that goes in front of the x. Plus the initial amount. What do you have to pay no matter what?
$12.
You have to get your dog a flea bath. Even if your dog doesn't have fleas, they can't just take your word for it. So they have to give your dog that bath. That is the $12.
Yeah.
So your equation, f of x, or your function of x, is equal to 15x plus 12. And then you have to apply the equation you made. So we need to know how much is it going to cost to board our dog for 8 days. 15 times 8 plus 12. Which is, whoopsie, 15 times 8 plus 12 is 132 buckaroos.
I knew it.
To board your dog for 8 days. All right, next one. You are in a cave 30 feet below the ground. You are descending at a rate of 9 feet per minute. Write an equation to find out how many feet below ground you will be after 25 minutes. So here's what I know. F of x, same thing though. F of x is equal to something times x plus something. It will always look like that. The rate goes first. So what's my rate? It tells you.
Feet.
Huh?
Feet. 9 feet
Per minute. 9 feet per minute. But it's not 9. It says you're descending. So does descending mean you're going up or you're going down?
Down.
down. So my rate is minus 9, right?
It's 9.
Plus my initial amount. Where did I start at?
30.
I-
Negative 30.
30 feet below. Below means negative, so this would be a negative 30. That's my equation. My function of x is equal to negative 9x plus a negative 30. Again, everything when you're given these word problems follows this template. So notice how right away I started with my f of x equals bar x plus bar. And then I just filled in and I identified what's my rate, what's my initial. Now I have to apply it 25 minutes. So negative 9 times 25 plus a negative 30. Negative 9 times 25 plus a negative 30 is negative 255 feet below whatever, the ground. Below the ground.
Low sea level.
Okay, so let's pretend we are in Chicago and we're getting a cab that charges $1.75 per mile. There is a flat fee of $10, so you gotta pay $10 no matter what to just even get into the cab. Write an equation to find out how much you will pay if you go 7 miles. So here's how I started. I always start with blank x plus blank. Okay, what's my rate? What changes? Miles, right? A cab, miles is what's changing. A cab can bring me 1 mile, a half a mile, a block, because I'm too lazy to walk a city block or something. I don't know. What varies is the mile. So pretty much though, if you're looking, you would want to write the per. Anything that says per is the rate. That's what's going to change. Okay, the per is the rate. So the 175 goes there. And then what's my initial? What do I have to pay no matter what?
$10.
Plus 10. And then you have to evaluate. So what I'm looking for in your homework today is that you make the actual equation and then you have to evaluate your equation.
It equals $2.
Dollar.
$2.25.
1.75 times 7 plus 10. Oh, 22, 25? Yeah, $22.25 to go. So,
even have it down.
miles. Okay, the next one, we can't follow that nice little template that I gave you. It's a little bit more advanced. So I'm going to just kind of show you how I work through this. I want to write a function, that means f of x, a function of x. I want to write a function for the area of a rectangle whose width is 5 more than the length. Here's how I start. What's my original equation for area? Length times width. Do you agree with that?
It does.
My original. So I start with original. Write it down. I start with the original equation. Then I modify it. So start with original, modify it. So it says whose width is, that's an equal sign. Width equals 5 more than the length. So length plus 5. Do you see where that came from?
Yep.
Okay, so I started original, and now I'm figuring out how I need to change it. Width is, that's my W equals 5 more than the length. Length plus 5. Now I have to change it. So now my width is something different. That needs to go where my other width is. So it's really length times my width, which is L plus 5. And there I go. That's the equation. You love it. So again, original, change as you need to. That's my process. First, original equation. The second thing I do is change. Okay? Write a function for the area of a triangle whose height is double its base. First, original. Area of a triangle is equal to, I don't know how you get, there's so many ways to write it. I'm going to say base times height divided by 2. Is that okay? You guys kind of all on